Стрим есть. Скорость что-то херовая. В чем проблема? Сейчас посмотрим, проверим. Идет стрим? Скорость плохая, да? Стрим есть, все, да, Димон, есть все. Не шебурши. Фу, так, ладно, погнала. Погнали.
Welcome back. You're making fantastic progress so far. Now that you've covered the basics of simple subqueries, let's learn how to construct correlated subqueries. Correlated subqueries are a special kind of subquery that use values from the outer query in order to generate the final results. The subquery is re-executed each time a new row in the final data set is returned in order to properly generate each new piece of information. Correlated subqueries are used for special types of calculations such as advanced joining, filtering, and evaluating of data in the database. Let's walk through an example of one of these queries. In the previous chapter, you completed an exercise that answered the question, which match stages, where the stakes get higher in each stage, tend to have a higher than average number of goals scored? You achieve this using three simple subqueries in the select, from, and where statements. However, that same output can also be produced with a correlated subquery. Let's focus on the subquery in the where statement. This query only has one difference. Instead of including a filter by season, the where clause filters for data where the outer table's match stage pulled from the subquery in from is higher than the overall average generated in the where subquery. The entire where statement is saying, in essence, return stages where the values in the subquery are higher than the average. Here are the results generated by this query. This may seem a bit complicated, but with a few more examples and a bit of practice, you will start to get the hang of how useful correlated subqueries can be. Let's quickly walk through some key differences between simple and correlated subqueries. Simple subqueries can be used in extracting, structuring, or filtering information, and can run independent of the main query. In contrast, a correlated subquery cannot be executed on its own because it's dependent on the values in the main query. Additionally, a simple subquery is evaluated once in the entire statement. A correlated subquery is evaluated in loops, once for each row generated by the dataset. This means that adding correlated subqueries will slow down your query performance, since your query is recalculating information over and over. Be careful not to include too many correlated subqueries, or your query may take a long time to run. Here's another, smaller example of a query in which you can use a correlated subquery. Let's answer the question, what is the average number of goals scored in each country across all match seasons? This is an easy enough question, right? You simply join the match table to the country table on the country's ID and extract the country's name, take an average of the goals scored, and group the entire query by the country's name, yielding one row with an average value per country. A correlated subquery can be used here in lieu of a join. Take a look at the outer query first. The name of the country is selected from the country table, aliased as C. The second column selected is a scalar subquery, selecting the average total goals scored across seasons from the match table. You'll notice that the where clause asks SQL to return values where the inner match table's country ID column matches the c.id column in the outer query's country table. This way, the entire join is replaced and the results are identical. Okay, it's time to practice using correlated subqueries.
Basic correlate subqueries. Что? Preparing database? Не понял. Это что было сейчас? Basic firing up SQL Server, preparing database. Первый раз вижу эту херню. Starting SQL client, initialize exercise. Ага, что-то прогружалось. Correlate subqueries are subqueries that reference one or more columns in the main query. Correlate subqueries depend on information in the main query to run and thus cannot be executed on their own. Correlated subqueries are evaluated in SQL once per row of data retrieved, a process that takes a lot more computing power and time than a simple subquery. In this exercise, you will practice using correlated subqueries to examine matches which scores that are extreme outliers for each country above 3 times the average score. Select the country ID, date, home call and away goal. Ну это с матч... Блин. Match is main. Main. Ну хорошо. Main. Main. Main country ID. Date. Хорошо. Main home goal. And away goals. Ну и main home. Ой, не home. Away goal. Okay. From match. From match is main. Where home goal plus away goal. More select subquery home goal. From match is sub. Main. Join the main query to this subquery in there. Country ID. Sub country ID. Main country ID и sub country ID. Sub country ID. Запускаем. Какая-то ерунда на самом деле. Типа одну и ту же табличку разделили. Это как self-merge. Что случилось? Почему? Сейчас. Очень напишу ребятам. Очень похоже на self Только код длинный, да. Select the country ID, date, home goal, and away goal columns in the main query. Ну, еще раз опять выбираем. Это у нас тоже как main. Main date. Main away goal, where filter for matches. Хорошо, home goal. Filter for matches with the highest number of goals scored. Complete the subquery. Select the matches with the highest number of total goals. Complete the subquery. Select the matches. Select the matches with the highest number of total goals. Ну, total goals это home goal плюс то есть меньше. Select. Дальше match the subquery to the main query using country ID and season. Окей, хорошо. Fill the correct logical operator so that total goals equals the max goals record in the subquery. Equals sub home goal. И тут main ой, нет, что это у нас? Filter the matches with the highest number of goals scored. Где main complete the subquery. Select the matches with the highest number of total goals. Match the subquery to the main query using country ID and season. Ну, то есть season и country ID. Main country ID, sub country ID и main season и sub season. Блин, какой красавчик, без ошибки. Классно. Так, немножечко света добавим. Ну-ка посмотрим. Да, хорошо. Nested subqueries, вложенные подзапросы.
Building on the previous lesson, another important type of subquery to learn is the nested subquery. Nested subqueries are exactly as they sound. Subqueries nested inside other subqueries. As you saw in the previous chapter, information in a database is often not in the format you need to answer a question. Some types of questions you answer may require multiple layers of transformation and filtering of data before you extract it into the main query. Let's start with an example. The query you see here is similar to the previous lesson, where we selected the average number of goals scored in a match within each country and compared it to the overall average using a subquery in Select. This third column calculates the difference between each country and the overall average. The resulting table looks like this, with one row for each country and one column for each of the two calculations. Let's answer a similar question with an additional layer. How does each month's total goals differ from the monthly average of goals scored? The query here, similar to the previous one, answers this question. Let's take some time to walk through the necessary steps to get this result. The subquery logic reads like this. First, select the sum of goals scored in each month. The month is queried using the extract function from the date. Here are the results of that first inner subquery, which includes results for months 1 through 12. Next, you can place the subquery into the second outer subquery to calculate an average of the values generated in the previous table, giving you the average monthly goals scored. Since this result is a scalar subquery, you can now place it in the main query for calculating the final dataset. Finally, you can place the entire nested subquery in the select statement, giving you a scalar value to compare to the sum of goals scored in each month. Here are the first 4 rows of the final query, which generates a sum of goals scored in the month and a column subtracting the goals scored from the overall monthly average. It's important to note that nested subqueries can be correlated or uncorrelated. They can also be a combination of the two. The inner subquery can be correlated, the outer uncorrelated, or vice versa. And each of the correlated subqueries can reference information from an outer subquery or the main query. It entirely depends on the problem you're looking to solve. Let's look at an example. This query answers the question, what is each country's average goals scored in a match in the 2011-2012 season? This is fairly similar to the previous chapter, except it takes one additional step. It has a second nested subquery inside the select statement, and the outer subquery has a statement correlating with the main query. The result you see here is a table with a column that identifies each country's average goals scored in the 2011-2012 season. Okay, let's practice creating some nested subqueries.
Вложенные под запросы, это капец, конечно. Nested subqueries. Please give a rating. Хорошо, ты мне дохуя хочешь у меня эти взять? Select the season and max goals scored in a match. Complete the main query to select the season, max, home, goal as select the overall max goals scored in a math. Complete the first simple subqueries to select the max total goals in a match across all season. Name the overall max home goal from match is overall max goals. Select then a max number of goals scored in any match in July. Complete the nested subquery that select the maximum total goals in a match plays in July across all season. Max home goal where ID in select to extract date as Julie max goals is select complete the nested subquery to select the maximum total goals. Played in July all season. Типа звездочка. ID in check the highlighted code the checker expect to find ID in the ID in ID. Вот так. Over max goal, Julie max goal. Хорошо. Generate a list of matches where at least one team score 5 or more goals. Where home goal больше равно 5, больше равно 5. Хорошо. Turn the query from the previous step into a subquery in the from statement. Хорошо. Setup of alias the sub country ID season count match IDs count ID from match select country ID season ID match home goal count the match ID is generated the previous step and group the query by count ID and season. Country count ID season. Хорошо, сгруппировали. Where home goal 5. Turn the query from the previous step into a subquery in the Так, я что-то ни хрена не пойму. Что это за ерунда? Ну. Or any goal. Окей. Так, home goal больше или равно 5, or any goal больше равно 5. Set up the alias of the subquery. Одну минуту. Так. А что это? Turn the query. Ну давай так, я не понимаю, нахрена это пропуски-то? А. From match. Вот так. From select. Все. Вот так. Теперь понятно. Уже начинаю соображать. Finally declare the same query from step 2 as a subquery in from with the alias outer s. Left join outer s to country. Left join table the using outer s. Okay. Calculate the average matches pair AVG. CNAME as country. Calculate the average matches per season. Что у нас? Count ID, season, count ID as matches from match, outer S, matches. Вот так. Да. Вообще не понимаю, как я решаю эти задачи. Очень странная фигня.
Great job getting the hang of nested and correlated subqueries. As you probably noticed, the queries we have been setting up are quickly becoming long and complex. It can become difficult to clearly keep track of each piece of your query, why you need it, and whether or not it's necessary. In this lesson, we'll cover a common method for improving readability and accessibility of information in subqueries, the common table expression. Common table expressions, or CTEs, are a special type of subquery that are declared ahead of your main query, just like you see here. Instead of wrapping subqueries inside, say, the from statement.
Common table X. Давайте-ка переведем это. Хотя что это? Show transcription. CTEs, common table expression. Общие табличные
You name it using the with statement, and then reference it by name later on in the from statement as if it were any other table in your database. Let's rewrite a query from an exercise that you completed in Chapter 2 by using a CTE. The query you see here uses a subquery, S, in the from statement to generate a list of country IDs and match IDs that meet a certain criteria. Specifically, we only wanted matches with 10 or more goals scored in total. This subquery is then joined to the country table, and the number of matches in the subquery is counted in the main query. Here are the results of that query: a short list of countries with very few high-scoring matches. In order to rewrite this query using a common table expression to represent the subquery, simply take the subquery out of the from clause, place it at the beginning of your query, declare it using the syntax with, followed by a CTE name, and as. So here, we're starting our CTE S by stating with S as, and then placing the subquery inside parentheses. It's now a common table expression. Finally, complete the rest of the query the same way you would if the CTE were an existing table in the database. You select the country name from the country table, count the number of matches in the CTE S, join S to the country table, and then group the results by the country name's alias. The results, you guessed it, are identical to the previous query setup. If you have multiple subqueries that you want to return into a common table expression, you can simply list them one after another with a comma in between each CTE and no comma after the last one. You can then retrieve the information you need into the main query. Just make sure you properly join the second CTE as well. So why are we learning yet another method of producing the same results in a SQL query? Common table expressions have numerous benefits over a subquery written inside your main query. First, the CTE is run only once and then stored in memory, so it often leads to an improvement in the amount of time it takes to run your query. Second, CTEs are an excellent tool for organizing long and complex queries. You can declare as many CTEs as you need, one after another. You can also reference information in the CTE declared earlier. For example, if you have 3 CTEs in a query, your third can retrieve information from the first and the second CTE. Finally, a CTE can reference itself in a special kind of table called a recursive CTE. We'll briefly discuss some more advanced applications of CTEs in the next lesson. For now, let's practice writing CTEs by modifying queries in exercises you completed in Chapter 2.
Set up the CTEs. Select. With matches as. Надо написать with matches list as country ID. Complete the syntaxes. Так, select the country ID and match ID. Match. Ну, просто ID надо выбрать. ID, хорошо. Home goal, okay. Select the count of matches from the CTA. Select lname as left join all Так, а что у нас тут? From match where? Хорошо. Select. Okay. Inner join. Match list on LID. Matches. Match list. Country ID. Вот так. Declare your CTE where you create a list of the matches. Короче, with match list as match as M. M лига. Где лига у нас? The select liga. Select the liga. Select the liga. Хорошо, подожди-ка. Date. home goal, and date, EMID, as Liga, select the Liga, filter the main query the matches with 10 or more goals, where 10 filter total goals равно 10 from select the Liga, date, home and away goals from match list, ID, date, home goal. Вот так. Select statement as the checker of the find Liga in here. Liga ID, Liga, блять, LAD, и тут вот так. LName. Ой. А тут LName. Все. Declare, так, хорошо. With match S. Select the Liga name. AVG home goal plus away goal, left join match list, create the list of match ID to filter data in extract from date, ноль восемь, 13-2014. Match list goals. Data. Select the liga name. Match list. The checker expects to find match list goals. Goals. Просто идти. Хорошо. Господи. Какая же дрочь.
At this point in the course, you're probably wondering why we're covering so many different methods of performing similar tasks. That's a great question. The simplest answer is that yes, there's a lot of overlap between use cases for joins, subqueries,
for sim.
and common table expressions. Many questions that you can answer can use these techniques interchangeably without sacrificing query runtime or the accuracy of your output. But these techniques are not identical. Let's take a minute to compare the techniques we've been using in this and the previous chapter. Joins allow you to directly combine information from two or more tables, and on their own are mostly limited to simple combinations and aggregations of tables already present in your database. A correlated subquery allows you to combine information between a subquery and a table or another subquery. These help you simplify your syntax and circumvent the limits of a join, namely that you can't join two separate columns in one table to a single column in another at a time. We saw this in the match table, where you can't retrieve the team name from the team table for both the home and away teams at the same time. A correlated subquery can solve that problem. However, it's important to remember that correlated subqueries take a long time to process and will slow down your query performance. Multiple and nested subqueries are useful when your data requires multi-step transformations before it's in the form you need for your final query. Breaking down the steps of your query process allows for better accuracy and reproducibility in your work. Finally, common table expressions allow you to organize your subqueries sequentially by declaring them at the beginning of your query. Since CTEs are processed one at a time before your main query, you can reference information from a CTE created earlier, thus serving as an alternative to nested subqueries. So which one do you use? Often, it really depends on the database you're using, the field that you're in, and the questions that you're asking. In general, I recommend that you practice each technique with your own databases to determine which one allows you to best use and reuse your queries and generate clear and accurate results. Before we move on, I'll share a few examples of questions that each of these approaches can be used for. As you've seen, joins are a universally important skill when working with a database that has more than one table. It's fair to say that joins are necessary to understand each of the following techniques. Correlated subqueries are great for matching data from different columns in one or more tables, such as determining who each employee's immediate supervisor is. Multiple and nested subqueries are great for answering questions such as, what is the average deal size closed by each sales representative in the last quarter, which would require multiple steps to transform and prepare before generating the final query. Finally, CTEs are excellent for comparing a large number of disparate pieces of information. For example, you may want to create a summary table examining the marketing, sales, growth, and engineering team's performance on their key metrics last quarter. With CTEs, you can extract data about each team's performance, one after another, and combine them into a single query. Okay, let's practice some variations on these techniques to see what your results would look like.
Left join team to match. Create a query at the left join team. Match from match SM left join team. Ну и что? В чем проблема? Ёб твою мать. Select mdate, get the home and away team names. Так, хорошо. Home team. Add a second subquery to the from statement to get the away team name, changing only the home ID. Left join both subqueries to the match table on the ID column. Пиздец. Join the home subquery to the match table. Warning: if your code is teaming out, you have probably made a mistake in the join and tried to join on the wrong fields, which caused the table to be too big. Read the provide code and comments carefully and check your own condition. Add a second subquery Date, get the home and away team names. Home team ID, away team ID, home team ID, away team ID. Да, хорошо. Left join the subquery to the match table. Join the home subquery. Окей, хорошо. Где что у нас тут в начале было? MID match. Match ID. Left join team ID as away. Home. Home ID, MID. Team ID. Select the home team. Где? Team где? Какой это? 24. Match. Sorry. Вот так. А в чем проблема? А в чем у нас проблема? Check the second entry, the home team ID, away team ID. Home team. Вот так. Да, потому что здесь away team. Как все запутано. Как оно все запутано. Connect the team to the match table. T connect the team to the match table. check the checker expect to find team IP ID. Team team IP ID EM home team ID, блять. Home team create a second correlated subquery in select. Так, что у нас в начале было? T и M. Окей. Теперь у нас тут T, а тут у нас M. Team IP ID, home team ID, select the home, M away team ID. Так, закончу. Ну, вроде бы... еще один, да? Угу. Select the match ID. M ID and team long and team long name. Team long name from match. Join team to team SD. Team to match using the team ID IP and home team ID. Team ID IP, home team ID. Вот так. Да. declare the setup. Let's declare the second away. Join to the cell the first. Жесткая фигня. Ой, это надо лучше перевести. Какую технику использовать? Предыдущие 3 упражнения показали, что во многих случаях для ответа на один и тот же вопрос SQL можно использовать несколько методов. Основываясь на том, что вы узнали, какое следующее утверждение относительно различий и использования производительности множественных вложенных подзапросов, коррелированных подзапросов и общих табличных выражений является ложным. Коррелированные подзапросы должны обойти множественные сложные соединения. Общие табличные выражения являются первыми, что улучшает время выполнения запроса. Так. Коррелированные подзапросы могут уменьшить длину вашего запроса, что улучшит время. Нет. Множественные или вложенные запросы обрабатываются первыми перед вашим основным запросом. Наверное, вот это. Да. Все. В общем, все. Пока все.